We are having this differential equation of order 1. We get dy by dx is in general form. We write here function of x, y. And you can see the solution of this one. We always write y is equal to c1 y1. We get only one arbitrary constant. If I have the differential equation of order 2, I can write in this form f of x, y, any function relationship with that one. So its order is 2, so we get here two arbitrary constants. We have y equal to c1 y1 plus c2 y2. If I having the differential equation of order 3, d3y by dx cube is a function relationship of x, y, y dash and y double dash. So the general solution will get, you'll get three arbitrary constants, c1 y1, c2 y2, c3 y3. So this we say is the general solution because it contains the arbitrary constants, and if we are having the conditions, initial conditions or boundary conditions, and we can find the values of these arbitrary constants, then we say that this is our particular solution. So here we can see that we having these functions. I take here, focus on this one. We have three functions, y1, y2 and y3. And this relationship, when we write like this one, this is called as linear combination. We call this one as linear combination. Linear combination. I usually call as a superposition of the solutions. Superposition of solution, because y1 is a solution, y2 is a solution, y3 is a solution, and we combine these three solutions. The question is, are we able to combine the solution all the times? Answer is no. There is one condition on these solutions y1, y2, y3 are the functions. They must be linearly independent. So we are going to introduce the new idea that we are having the functions as linearly independent and we are having the function linearly dependent. So we introduce two ideas. Number one is linearly independent. Linearly independent, very simple one. We are given here three functions, y1, y2, y3. Obviously, when there are functions, there is a domain. We say there are on the interval I. So we want to say they are linearly independent on this interval. They are linearly independent if you get the linear combination c1, y1, c2, y2, and c3, y3, and put this equal to 0. We say this is 0 only if we are having here c1 equal to 0, c2 equal to 0, and c3 equal to 0. Then we say the functions are linearly independent. And we say when they are linearly independent, if y1, y2, y3 are linearly independent, only in that case we can write the solution as a linear combination of y1 and 2, that's c1 y1 plus c2 y2 plus c3 y3. Then we can find the general solution. We write the linear combination. The condition is that they must be linearly independent. The second idea is number 2, linearly dependent. Linearly dependent. So obviously we have the linearly independent. We can immediately see the definition of linearly dependent, because this is something which is related with the different from the linearly independent. Linearly dependent. So we have the functions y1, y2, y3 on interval I. So we are having this combination c1 y1, c2 y2 plus c3 y3. This is 0. But c1, c2, c3 are not all 0. Here we say they must be 0. This will become the difference. Here what we say, linearly independent. Linearly independent is when they all are equal to 0. Linearly dependent when they are not all equal to 0. So we can say the function will be, so here we can't write the general solution. We can't write the general solution. So I'm just going to explain you the idea of linearly independent and linearly dependent. So there are two types of the things which we are going to come across. Number one, we have the functions y1, y2, y3, general functions. We discussed they are linearly independent, linearly dependent, number one. Number two, we have y1, y2, y3 solution of the differential equation. And then we want to see that we can write the general solution or not. But anyway, we have to understand that when they are linearly independent and then linearly dependent, because when they are linearly independent, there is a possibility that we write the general solution. Before I go further, I just want to mention that I have the notes for this one. If you go to the description, then the Google Drive, I give you the note, the link for that one. You just click the link and you'll get the notes for my lecture. Also, you'll get the extra examples, extra exercises for doing the practice. So if you want to continue that one with me, then you subscribe our channel. Also, you press the bell icon so that you get the notification. So in this way, you continue this one. Otherwise, we'll be putting the material and you got it. Oh, fine. Anyhow, by that one, you'll be regularly attending our lectures. So next is, I want to show you that how we can say that they're linearly independent and linearly dependent. I will try to explain you with the help of example, and then I can show you, because for the general solution it's absolutely important that we must have the equation as linearly independent and linearly dependent. So I'm having here the example we want to determine. Example is example 1. Example 1, determine whether the functions y1 is equal to cosine square x, y2 sine square x, y3 cosine 2x are linearly independent It may be in a linearly independent, it may not be linearly independent. So solution of this one, we take the linear combination of this one, put that equal to 0, that's here, as we said it, then we take C1, Y1, C2, Y2, C3, Y3, put this equal to 0. We're having here C1 cosine square x, C2 sine square x, C3 cosine 2x equal to 0. Here you must know the formulas for the trigonometric functions. We're having here cosine 2x is equal to cosine square x minus sine square x. We use this formula and we replace, because there are some cosine square, sine square is cosine 2x. We change the function, we get here C1 cosine square x plus C2 sine square x plus C3 cosine square x minus sine square x. We put the value of cosine 2x. Open this one, we get C1 cosine square x, C2 sine square x plus C3 cosine square x minus C3 sine square x equal to 0. Now we want to find the value of C1, C2, C3. We were able to find, we get the value of C1, C2, C3 and put it in, this becomes 0, it means they are linearly dependent. And we find the value and all they are equal to 0, it means they are linearly independent. Now we compare the coefficients of cosine square x. So when I compare the coefficient, this here is C1, this here is plus C3, and this is equal to, on the other side is 0. The coefficient of sine square is 0, cosine square is 0. So we compare the coefficient of sine square x, that's become here C2, then here minus C3 equal to 0. So we can see it here that our C1 is equal to minus C3 and our C2 is equal to C3. Now because we have three unknowns, C1, C2, C3, So as we discussed, so 1 is independent. So we say let C3 equal to 1. When I take C3 equal to 1, then I get here C1 equal to minus 1 and C2 equal to 1. This means if we substitute the value of C1 here, they become 0. So if I substitute here in this equation here, what I'll get, C1 is equal to minus 1 minus cosine square x. C2 is 1 plus sine square x. Then C3 is 1 plus cosine square x minus sine square x, and we can check it that we're having here cosine square x with minus sine, cosine square x plus sine to become 0. Then we're having sine square x with plus sine, so sine x is 0. This means we'll find the values of C1, C3. So C1 is equal to minus 1, C2 is equal to 1, C3 is equal to 1, which makes this combination this equal to 0. So what we said, if this is 0, when not all c's are 0, then the functions are linearly independent. So we say our functions here we can write here y1 is equal to cosine square x, y2 is equal to sine square x, and y3 is equal to cosine 2x are linearly dependent. So in this case, as you mentioned, that we can't write the linear combination, we can't write the solution. So this is the idea, that we want to determine the type of the function, they are linearly independent or not, whether this is, we find they are not linearly independent, or linearly dependent or not linearly independent. Or we can write more correctly is are not linearly, because our question was whether they are independent, so answer is not linearly, are not linearly independent.